Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the further mechanics paper 3, May-June 2024 paper 33. Let's take a look at the first questions. Two smooth uniform spheres A and B of equal radii have masses m and 2m respectively. The two spheres are moving on a smooth horizontal surface when they collide with speed u and half u respectively. Immediately before the collision, A's directions of motion is along the line of center, and B's directions of motion makes an angle theta with the line of center. Okay, as stated in the diagram. Okay, as a result of the collision, the directions of motion A is reversed and the speed is reduced to 1/4u. The directions of motion B makes an angle theta with the line of center, but on the opposite side of the line of center. The speed of B is unchanged. Okay, so find the value of the coefficients of restitution between the sphere. We are looking for the E. Okay, so now what should we do is usually we just draw the diagram to represent the before and after. Before, the directions of the A go like this, and is a U. This is the M. Then the B go like this. This is a 2M with the angle theta here. After, they mentioned that the A direction is reverse and is reduced to become 1/4u. But the B direction is opposite, okay, and theta as well, but it's opposite and it's unchanged. It's still it's still half u over here. So this is the directions of the motion of A and B before and after. So what we can do is we just consider the their horizontal component. Okay, just consider the horizontal component over here. So if you consider the horizontal component by the PCLM, the principle of conservation of linear momentum, your mu plus the 2m of negative half u cos theta is equals to the m of negative 1/4u plus the, oh, oops, not enough space. My apologies. Let me write it below here. So it will be mu plus the 2m of negative half u cos theta equals to the m of negative 1/4u plus the 2m half u cos theta. So you can cancel all the mu. If you cancel all the mu, you get 1 minus the cos theta equals to the negative 1/4 plus the cos theta. So from here, you can find your cos theta is equals to 5/8. Okay, so this is how you get the cos theta. Then you consider the NEL, Newton experimental law. Okay, your E is equals to the negative of the VA minus the VB. Okay, so your VA is a negative 1/4u minus a VB is a half u cos theta. Your cos theta is already known as a 5/8. Okay, cos theta is already known as a negative as a 5/8. Then the UA is a u minus the negative half u cos theta as well. So if you cancel all the u here, you can get this as the 1/4 plus 5/16, 1 plus 5/16. Press a calculator, simplify it, you will get this E as a 9 over 21, or you can make it become 3 over 7. Done. That will be the answer for the question number 1. Now we move on to the question number 2. Okay, now we take a look at question number 2. A particle P of mass m is attached to one end of a light elastic string of natural length A and modulus of elasticity 2 mg. A particle Q of mass km is attached to the other end of the string. Particle P lies on a smooth horizontal table. The string has part of its length in contact with the table and then pass through a small smooth hole in the table. Okay, so according to the descriptions, this is the table, and that is a small hole over here, H, and there's a string passed through this small hole. This is a Q, this is a P, okay? And particle P move in the horizontal circle on the surface of the table with contact with the speed square root of half GA. Particle Q hangs in equilibrium vertically below O, with the HQ is equals to the 1 over 4. So the HQ is a 1 over 4A. Okay, so this is the tension. This is the tension. The weight of the Q is kmg. And then the mass of the P is m. Okay, so if you consider the new Hooke's law, if you consider the Hooke's law, T is equal to the lambda x over the, the 2L. So your tension is equals to the, what is the lambda? Lambda is a 2 mg. Hey, sorry, I write the formula wrongly. Lambda x over L. So L is a. So then at Q, if you resolve the forces vertically, you have the T is equal to the kmg. Okay, so you have this equation 1 and equation 2. Let the equation 1 equal to equation 2, you have the 2 mgx over A is equal to the kmg. So over here, if you cancel the mg, you get that the k is equal to the 2x over A. Okay, so this is what we have at the very beginning. Now we have considered Q. Now we want to consider P. At P, if you resolve the forces, this time they resolve the forces horizontally because P is moving in the horizontal circular motion. So you will have the T is equals to the mv square over the r. Okay, and since we already have the T as a kmg, okay, so we put this kmg is equal to the mv square. So this one, if you take the v, if you square it, it will be half GA. Okay, and this is your R. Okay, so your R is the R is so-called the HP lah. Maybe I call the R as a HP. So you cancel the M and G. Okay, so you get this HP, KHP is equals to the half A. Okay, but our K is already, okay. K we already know is 2x over A. Okay, so we just change this to become 2x over A. Okay, then what is HP? Okay, over here we need to deal with the HP. We know that the HB plus HQ is equals to the A plus the extension. So the HB is equal to the A plus extension minus the HQ. HQ is a 1 over 4A. So your HB is actually 3 over 4A plus X. So we change the HB become 3 over 4a plus x. So we multiply everyone by 4a. If you multiply everyone by 4a, then you will get this as the, sorry, I should expand first so that this one I get 3 over 2 ax plus the 2x squared is equal to the half a squared. Okay, I multiply by a first, easier. 2x squared. So it's 2x squared. Now after that, I multiply everyone by 2. I get 4x squared plus the 3ax minus the a squared equal to 0. So you try to factorize it. Over here, it will be 4x plus a minus a. So your x is equal to a over 4 and x equal to negative a. Since the x is a length, it cannot be negative. Just ignore the negative a. So therefore, your answer for x is 1 over 4a. So done. Okay, so we have done with this. And now we want to find part B. Part B is to find k. Okay, so based on the result here, based on this result, k is equal to 2x over a. K is equal to 2x over a. Therefore, you have a 2 of a over 4 over a. You get k as a half. Done. So this will be the answer for the part B. Okay, now we move on to the question number 3. Okay, question number 3. A particle P of mass m is attached to the one end of a light inaccessible string of A. The other end of the string is attached to a fixed point O. When the particle is hanging vertically below O, it is projected horizontally with a speed u that's begin to move along a circular path. When P is at the lowest point of its motion, the tension of the string is T. When OP makes an angle theta with the upward vertical, the tension of the string in the string is S. Okay, so this is a vertical circular motion. This is the at the beginning. You have here T, then the mass is the mg. Okay, then your speed over here is u, and then later when you reach to here, that makes the angle theta with the vertical upward vertical. Okay, then this time your speed, they didn't mention the speed. Okay, so we do not know the speed, just have a v here. So this is the circular path. Okay, so from here we need to do the conservations of energy. We have the GPE gain, and it will give you to the KE loss. So the GPE gain is mgh, KE loss is a half m of the u squared minus a v squared. Simplify it, you get v squared equals to the u squared minus a 2gh. Okay, so this is the first equation that I have. But the h, we can still find the h. The h is over here. So the h will be, it will be a plus the a cos theta. So you can factorize the a out, make it become 1 plus cos theta. Okay, so this is my equations of v squared in terms of u and theta. Then at the lowest point, you have the t minus the mg equals to the mu squared over the a. Okay, then you get t is equals to the mu squared over a plus the mg. Okay, so yeah, this is the tension in the lowest point, but we want to show that the S equals to the D minus the 3 mg cos theta. Oh, that means since I want the answer in terms of D, then I need to replace the U. Okay, that means this equation is not suitable. We need to erase this. We want to make this become in terms of U square. So your U square will be the A over M D minus mg. So this will be okay. This is what we have. Then continue at the point. At the point, they say OB makes an angle theta with the upward vertical. Okay. So when you are at this point, so let's say this point at the upper side lah. Okay. So we can just say that. Okay lah, this one no need lah. We just say this is the tension S. Okay, so at this point, so if you resolve the forces towards the center of the circle, you have this is your mg, this is a theta. So you have S plus the mg cos theta is equal to the mv square over the A. Okay, so if you replace S equals to the m over A v square, v square is replace it with this. You have this as the u square minus the 2ga 1 plus cos theta minus the mg cos theta. So over here you have a mu square over A minus the 2mg 1 plus cos theta minus the mg cos theta. So we have these equations. We want to put them inside here. Okay, so if we substitute them inside here, then we will get this as the m over A over m d minus mg. This one is the minus the 3mg cos theta minus the 2mg. If we expand them. So this cancel. At the end, you get t minus the 3mg 1 plus cos theta. Okay, just like that. If you expand, simplify them together, then this is what you have shown. This is how you show the answer in the part A. Then I move on. B, now they give you u equal to the square root of 4ag. That means the u square is a 4ag. Find the value of cos theta when the string goes slack. Okay, so over here, we just copy down these equations. We copy down this equation t minus the 3mg 1 plus cos theta from the part A. So when they go slack, that means when s equal to 0, when we supposed to write like this, when u equal to the square root of 4ag, s equal to 0. So 0 is equal to d minus the 3mg 1 plus cos theta. So your t is equal to the 3mg 1 plus cos theta. Okay, then we have u. So we just change the using these equations. Okay, or maybe we use this one better. Okay, so if we use these equations, T minus mg equals to the mu square over A, that will give you the T is equals to the m over A. Your U square is a 4AG, 4GA plus the mg. So over here, you will get this as the 5, you will get this one as a 5 mg. So I call this one equation 1. I call this one equation 2. So 1 equal to 2, you have the 5, you have the 3 mg cos theta, 3 mg1 plus cos theta equals to the 5 mg. Cancel the mg. At the end, you get your cos theta is equal to the 5 over 3 minus 1 is equals to the 2 over 3. That is the answer for the cos theta. Okay, done for this question number 3. Now we move on to the question number 4. Okay, now let's take a look at question number 4. A light spring of natural length A and the modulus of elasticity kmg is attached to a fixed point O on a smooth plane inclined to the horizontal at an angle theta, where the sine theta is equals to the 3 over 4. A particle of mass m is attached to the lower end of the spring and held at the point A on the plane where OA is equal to 2A, and OA is along the line of the greater slope of the plane. The particle is released from rest and moving with the speed v when it passes through the point B. So when it passes through the point B, your speed is v. And where the OB is 3 over 2a, the speed of the particle is half of the v when it passes through the point C on the plane, where the OC is equals to the 3 over 4a. Okay. So over here, definitely we need to use conservation of energy, but we have 2 situations. I will consider A to B first. Okay, A to B. We consider the conservations of energy. If you're moving A to B, that means you're moving from here to here. Okay, so if you're moving from here to here, you have the speed gain, KE gain. Okay, your GPE also gain. But your EPE is lost. Okay, so KE gain, it will be same as a half m of the v square minus a 0 square plus the mgh. Your h is over here. This is a h. This is a theta. And from A to B, the distance is 2a minus a 3 over 2a. So this is actually a half a. So the h is actually half a sine theta. H is actually half a sine theta. Equals to the EPE loss. EPE loss. Okay, I think to save space, I don't write like this one first. I just write MGH. EPE loss will be a lambda over 2a of the x. Your tension. Originally, your extension from A is a square minus the extension for the B. This one is a 3 over 2 minus the A. 3 over 2 minus A. 3 over 2A minus A, it will be half A. Okay. So now we simplify it. Just now I told you A is a half A sine theta. Sine theta, I direct H half A sine theta. What is your lambda? The question mentioned that the lambda is kmg. So this one, if you expand, simplify, you get this one as a 3 over 4 A squared. Okay. Then we have this as the cancel the half, cancel the A. So you have this as the cancel the M as well. You have a V square plus the GA sine theta is equals to the 3 over 4 kGA. Okay, so your V square will be equals to the 3 over 4 GA K minus 1. Okay, we get these equations. So we not able to find the V at the moment. Okay, so we have to leave it like that first. Then now we consider A to C. We also consider the COE. Repeat the same process. So the formula still the same. KE gain is plus the GPE gain is equal to the EPE loss. So KE gain is half M of the this time the speed has become half V minus the 0 plus the MGH. The H is will be from A to C. This H, this is the H number 1. This is the H number 2. This is the data, the H to C, A to C. The distance is actually 2A minus the, just take the 2A minus the 3 over 4A. So actually it's a 5 over 4A. So 5 over 4A cos sine theta. This one is a 5 over 4A sine theta equals to the lambda over 2A. Your extension is A square minus the so the extension for this one it becomes shorter already because the original length is A. So the compression, this is compression over here is only 1 over 4A. And you square it. So this one is no longer stretching, it's compressed. Okay, so just like that. Then you can cancel the M. So you have this one as a 1 over 8 V square plus the 5 over 4 GA sine theta equals to the kg over 2A. This one, press the calculator. You have this one as the 15 over 16 A square. Simplify further, you can get this one as the 15 over, oh, okay, I think I can multiply everyone by 8. I get the V square plus the 15 over 2GA equals to the 15 over 4 kGA. So your V square will be the 15 over 4 GA K minus a 2. That will be your equation number 2. So this is what we need. So both of the equation 1 and 2, they are in terms of V square. Just let the equation 1 equal to the equation 2. Then we almost there. 3 over 4 GA K minus 1 equal to the 15 over 4 GA K minus 2. Cancel the GA, cancel the 4. Cancel the 3, you get a 5. So you get K minus 1 equal to the 5K minus 10. Then you get the K as the 9 over 4. Just like that. Done. That will be the answer for the question number 4. Only one part. No more, no part B. So now we move on to the question number 5. Number 5. A uniform lamina is in the form of triangle OBC with the OC equals to the 18A, OB equal to the 24A, and COB is at 90 degree. The point A on OB is such that OA equal to X, and the triangle OAC removed from the lamina. Find in terms of A and X the distance of the center of mass of the remaining object ABC from OC. Okay, from OC, that means it's from the vertical axis. Okay, so for these questions, nothing special. We just need to build the table. Okay, we have the lamina. So we have a triangle. Big triangle is OBC. Then the small triangle is OAC. And we have a triangle of ABC. So this is the area. Since they are the same material, just consider the area we do. Half times base times height. So it will be 216A square. Then a half times base times height, you have a 9AX. So if you minus it, you have a 216A square minus a 9AX. Your center of the mass from the AC, from the OC. So if from OC, then this will be bar X. So for triangle, actually, this case, it will be 1/3. Okay, so 24 here, right? So you cut them into 3 parts. So it will be here 1/3 of it. Okay, so it will be 1/3 only. So it will be 1/3 over 24A. It will be 8A. So same thing happen over here. You cut this X into 3 parts. Your center of the mass will be here. So it will be 1/3 multiplied by X. Okay, so this is the center of the mass from the OC. Then take the moment about OC. And you have a 216A square multiplied by 8A minus the 9AX multiplied by 1/3X is equals to the 216A square minus the 9AX bar X. We simplify it first. Okay. So we can direct take this whole thing divide. Take this whole thing divide to the other side. So we can have the bar X. Your expand everything over here. You will get this. I think we can. Wait, let me press a calculator. 216 multiply 8. 1728. All of them have A. We can cancel the A. Okay, so this one become A square minus the 3X square divided by the 216A minus the 9X. So if you simplify further, all can divided by 3. All can divided by 3, you get a 576A square minus X square divided by the 72. A minus the X, 3X minus the 3X. Okay. So this is the answer already. But actually, if you look at them carefully, because 576 is actually a square number. 576 is a square number. It's actually a 24 square. So 24 square, actually, you can factorize, become 24 plus A plus X and 24A minus X. If you can see them in such a way, that it will be better. you can factorize them. Then your denominator, actually, if you take the 3 out, it will be also 24a minus x. So you can see that these two can cancel off. At the end, your bar x will be the 24a plus x over 3. Okay, so this will be the answer for the A, for the part A. Okay, your bar x is equals to 24a plus x over 3. Now, we move on to the part B. They say that the object ABC suspended from C in equilibrium positions. It's the side AB makes an angle theta with the vertical where the tangent theta equal to 6 over 5. Tangent theta equal to 6 over 5. Okay, so these are the information given. And we just assume that from the diagram, we just assume that this is the center. The center is here. Okay, this is the bar X and the bar Y, the center of the mass. So we hang at the point C and we let it hang, let it go equilibrium naturally. Then you connect this point C and the center of the mass with a straight line. If you connect it with a straight line, okay, okay, I draw freehand, so straight line is not so nice. We will consider that this is a straight line. So this is actually your vertical. Okay, then your AB makes the angle theta with the vertical. Your AB makes an angle theta with the vertical. Okay, so from here, we want to find the theta. Okay, we want to find the theta. So this theta, you can see that this is also the theta. We know that this is the x, but it's just that we need to know what is the height over here. So to find this height, we need to know the bar y. We need to know the bar y because this is the bar y. Okay, these two add together, it will be 18a. So I need to find the bar y. So to find the bar y, just need to extend this table from here. Okay, so how do we find the bar y? The bar y, you just take, because actually this two triangle is actually, they are having a same height. These two triangles, they're having a same height, 18a. So the center of the mass from the OB, it will be 1/3 of the 18a. It's a 6a. This is also 1/3 of the 18a, 6a. So since this is the same 6a, that means your bar y also will be a 6a. So you need to show this table so that you can explain how to get the bar y is equal to the 1/6. Your bar y equal to 6a. So just write the bar y is equals to the 6a. Okay. You already explained that in the table in part A. So this you can straight away just write down the bar y equal to 6a. No need to do any calculations. However, if you want, you can take the moment about, okay, you can take this moment about the OB. You can show that the bar y is a 6a. But which I think no need because as I have told you just now, if you draw this table, since these two values are the same, then your bar y automatically will be also the same, 6a. Okay, so I straight away, since I already mentioned that in the part A with the table, so I just directly write the bar y as 6a. Okay, so maybe we just say that from A, from part A. Okay, so now because based on the triangle that I draw just now, this is the bar x, then I want to find the h. So your tangent theta is equals to the 18a minus the bar y divided by the bar x. Just write like this. Then your tangent theta is 6/5. Your bar y is 6a. your bar x is a 24a plus x over 3. Okay, so I join together, bring it up, make it become 18 over 24a plus x. Oh, sorry, I make a mistake. Do the cross multiplications. You get this one as the 48a plus the 6x is equals to the 90a minus the a. This one is 12a times 5, 60a. So your x is equals to the 12a over 6. X 12a over 6. Oh, sorry, I make a mistake. This one is 2, not 6. 12a over 2. So the answer is a 6a. Okay, so this is how we get the answer for the part B. And that's it for this question number 5. Now we want to move on to question number 6. Okay, now we take a look at question number 6. A particle P is projected with a speed u and an angle theta above the horizontal from a point O and move freely under gravity. After 5 seconds, the speed of the P is 3 over 4 u. Okay, so since they mentioned speed, that means we need to find the speed is the v. Okay. Then they mentioned time. So over here, we need to start from the horizontal component, horizontal displacement and the vertical displacement. So your x is equals to the, okay, so your x is equal to the u cos theta d. Your y is equal to the u sine theta d minus a half the gt square. Since they mentioned speed, I need to find the x dt. It's a u cos theta. I need to find the dy dt. Then it will be u sine theta minus the gt. Okay, so my when the d equal to 5, when the d is equal to 5, your v is equals to the 3 over 4 u. So your v square is equals to the 9 over 16 u square. Your v square is actually x dt square plus the dy dt square. This is the formula. So your dx dt, just put it inside. You have a u cos theta square plus the u sine theta minus the gt square. They already tell you that the d is 5, so it's a 5g. It's a 5g. But you can see that the equation that they want you to show over here, no g. So no g, that means we just change our g become 10. Just change the g become 10, maybe become make it become 50. Okay, like that. So you just expand u square cos square theta plus u square sine square theta minus the 100 u sine theta plus the 25 2500 equals to the 9 over 16 u square. But we know that these two combined together, you will get a u square because cos square plus sine square is a 1. So you have u square minus a 9 over 16 u square minus a 100 u sine theta plus the 2500 equal to 0. So at the end, you get this as a 7 over 16 u square minus a 100 u sine theta by the 2 plus the 2500 equal to 0. So done. That will be the answer for the question number 6A. Now we move on to the 6B. It is given that the velocity of the B after 5 seconds is perpendicular to the initial velocity. So now we are talking about the perpendicular, the directions of the motion perpendicular to the original motion. So I need to find dy dx. dy dx is a dy dt over the dx dt. So I just use a formula. Use dy dt from the part A. We already have this as the gt. This one is a u cos theta. Okay. Then when the t equal to 0 at the very beginning, your m1 or the so-called dy dx is a u sine theta over the u cos theta, and it's equals to the tangent theta. Then your t equal to 5, you are having a m2. m2 will be the u sine theta minus a 5g. I make it 50 since I already changed the g become 10. So I make it become 50 over the u cos theta. So it is given m1 times m2 equal to -1 because they are perpendicular. Okay. So okay, I think cannot say given because actually the question didn't mention m1 times m2 is a -1. They only mentioned that it's perpendicular. So we just direct write m1 times m2 equal to -1 will do. So that means tangent. Since I have sine cos, I think we want to find sine theta. Okay, I think better we don't use sine theta, tangent theta. It's better we remain this tangent theta as a sine theta cos theta multiplied by u sine theta minus a 50 and the u cos theta equal to the -1. So you have a u sine square theta minus a 50 cos theta is equal to the -u cos square. So you've joined together, you get a u cos square plus sine square. We get this is equals of this. I multiply wrongly. This one is not cos, it's a sine. Then this is a 50 sine theta. So we know that the cos square plus sine square is a 1. Therefore, I have the u is equals to the 50 sine theta. So I need to find sine theta, right? So I just need to use these equations. I call this one equation number 1. I call this one equation number 2. 2 into 1. So you get this as a 7 over 16 of the u square minus a 100 u sine theta, 100 the u sine theta plus the 2500 equal to 0. So you expand, you get this as a 7 over 16 of 2500 sine square theta minus the 5000 sine square theta plus the 2500 equal to 0. So just use your calculator, simplify it. All the sine square joined together. At the end, you get the sine square theta will be equals to the 16 over 25. If you just use your calculator to simplify them, then your sine theta is equals to the 4 over 5. Okay, because your theta is a cube. Okay, your theta is a cube. So you can only take the sine theta as positive. But we are looking for sine theta. Oh, we're looking for u as well. Okay, so okay. So when sine theta equal to 4 over 5, from the equation number 2, your u is 50 times 4 over 5 is a 40 meter per second. Done. This will be the answer for the question number 6, part B, 6 part B. Okay, so now we move on to the question number 7. Okay, now we take a look at question number 7. A parachutist of mass mkg is open his parachute when it's moving vertically downward with a speed of 50 meters per second. At time t second after opening the parachute, he has fallen the distance x meter from the point where he opened his parachute, and his speed is v meter per second. The force acting on him are his weight and the resistive force of magnitude mv, Newton. Find the expressions of v in terms of t. So for these questions, it's actually a free fall, just fall vertically downward. So over here, if you consider the vertical force, you have a mg minus the air resistance, or the resistive force, is equals to the ma. So your resistant force is mv equals to the ma. Cancel all the m, you get a is equals to the g minus the v. But the answer here, they want v in terms of t. So there's didn't mention in terms of g as well. So we just write this a as a dv dt. This one is a 10 minus a v. Then you just need to integrate them. Just do the separable variables. This one integrate, direct, use the formula. Remember to put the modulus. Okay. Then when the t equal to 0, your speed is a 50, because they mentioned that at the beginning, when you start to open the parachute, your speed is a 50 meters per second. So it's a negative ln of negative 40 equal to 0 plus c. So the modulus of a negative 20, it will make the negative 40, and the modulus of negative 40 will make the negative 40 become positive 40. So your c is a negative ln 40. Put the c back into the equations above here. We still have the modulus with us. Join together, your t will be a ln modulus of 40 over the 10 minus a v. So you have a modulus of 40 divided by 10 minus v equal to e power t. Now when we take away the modulus, we actually need to consider plus minus et. So we should choose plus or should choose minus to fulfill this condition. That means if you replace t equal to 0 and the v is equals to the 50, in order to fulfill the equation, then you have to choose negative. So over here it will be a negative. So it will be 40 equal to the negative 10 plus the ve power negative t. Hey, sorry, I multiplied wrongly. I supposed to have 40 e power negative t equal to negative 10 plus v. So the v is equal to 10 plus the 40 e power negative t. Like this. That is the answer for the v in terms of t, done for the part A. Now we move on. Part B, find the expression x in terms of t. So from the v equal to 10 plus the 40 e power negative t, my v can be written as a dx dt. This one will be simple already. So your x is equal to integrate 10 plus 40 e power negative t dt. So it will be 10t minus a 40 e power negative t plus the t. Then given when the t is equal to 0, your x is a 0. So you have a 0 equals to the 0 minus a 40 plus the d. So your d is a 40. So therefore, your x will be a 10d minus a 40 e power negative d plus the 40. Okay, just like that. That is the answer for the part B. Quite straightforward. Then now we go for C. Find the distance of the parachutist has fallen since opening his parachute when the speed is 15 meters per second. Okay, so just say that when the V is equal to 15, from these expressions, from the expression here, change the V become 15. So this one is a 15 equal to the 10 plus e to the power of negative 40 e to the power of negative 40t. Negative e power e to the 40 multiply e to the power of negative t. So your it will be e power negative t is 1 over 8. So your t will be negative ln of 1 over 8. You can write it as a ln 8. I will remain them in the exact value form first. Okay. Then when t is equal to the ln 8, what will happen to your x? So this one is right. Your x will be the 10t minus the 40 e to the power of negative ln 8 plus the 40 based on the equations here. Change the t become ln 8. So this one it will be 10 ln 8 minus the 1 over 5 plus 40. Okay? And not 1 over 5. This one is a 5. Then you get 35 plus 10 ln 8. You can give the answer in decimal. It will be 55.8 meter. Done. That will be the answer for the question number 7C. And this will be the last questions for this paper. So I will stop the video here. I'll see you next time. Bye-bye.